Hello, my name is Merlin. I'm with DC949 and DC310 and currently working in Los Angeles at a startup where I implemented this technique for the first time. It's called Ouroboros. That's the name of the scripts that I produced, which will be available to you guys after the conference. Essentially, I'm going to hop right in. The network is slow. All right, well, that's a drink for me. Sorry, it's not my laptop either. Go. Sure. All right. If you can hit that, you can probably get the talk. There we go. All right. Now the network's cooperating. So, what is Ouroboros? It's basically using ZFS, FreeBSD, and a whole bunch of various scripts, mostly written in Python, to manage this system. And you may have remembered from the talk opening, I mentioned I'm basically setting up a cloud system. What I mean by that is I wanted something to basically deploy many systems for special purposes so that I could have little tiers of stuff, easy to manage, pretty much like EC2 or Rackspace or any other cloud provider that you're familiar with. Only I wanted to do it myself on my own hardware and for free. But of course, nothing is free. So for my system, you will need FreeBSD. I started working with FreeBSD 7. That's the first FreeBSD to have ZFS built into it. You're going to want ZFS version 3 or greater. Most things now are about version 5. There's like a version 6 file system, I think, about to come out on the pipe. So it's all constantly moving, but you just got to stay up to date. Or you could try it yourself on another system, which we'll talk about later. Whoa. All right. Hard to click. Yes. Okay. So, if you weren't aware of what ZFS is, it's basically Sun's file system that they invented and licensed. It's a binary tree file system with copy on write semantics, which basically makes it very performant under pretty much all circumstances. It also adds a whole bunch of other stuff. Well, the only circumstance you lose is you need a lot of memory and a lot of space because you're going to be constantly moving stuff around. However, Sun, has a lot of engineers and stuff, so they spend a lot of time and money producing quite a lot of tools to make ZFS a really, really nice system. Essentially, with ZFS, you get the ability for individual file systems to take a specific pool of devices. You can set up mirroring on those. You can set up extra devices for caching, extra devices for write logging, all those kind of things to increase performance and reliability. With ZFS, you can do snapshots of whole partitions, and most importantly for this system, with ZFS, you can send and receive those snapshots between systems. Oh, and then also on the slide, I note FreeNAS, which is a FreeBSD-based home NAS system that has been using ZFS for some time. So what are jails? Jails are a core feature of FreeBSD. Sometimes they're known as like a super CH root. Essentially, what they do is they use the same kernel with some extra protections in between for process blocking and stuff, but you use the same devices, all of the same everything, just like on the real system. It's kind of similar to OpenVZ, if you know that system. So you get quite a lot of performance for these little virtualized systems that you create. And ostensibly, they're also secure enough so that people can't break into the host system. For my purposes, the main benefit is that they're lightweight. If you're Linux or Oracle fan, because Sun is now dead, you could be looking at Linux containers. This is a recent feature of the Linux kernel. It's pretty much similar to jails. On Solaris, there's what they call zones. Also, ZFS has found its way to Linux. It's ZFS on Linux, obviously. And basically, on Linux, they use gmake. My system uses BSDmake, so my system will not be portable to Linux, but you could go ahead and have a shot yourself. Also of note, ButterFS exists. That's Linus's attempt to make a ZFS-like system. However, he doesn't quite have the whole tooling yet, so you might want to look at ZFS on Linux. I just want to take a short break while I plug this in to ask a simple question. Where is Virus? Seriously, where is he? Doesn't matter. Doesn't matter. All right. So currently with this system, you need to set up a first environment, which is following the original requirements. You need a server, probably several, running FreeBSD. They need to have ZFS on them. My systems run ZFS on the root, so every file system on the system is ZFS. Then you need my scripts, the Ouroboros scripts. From there, you can simply do a build world and install it into a jail, which is in FreeBSD, they live in a specific file system. I don't know if you remember from the original slide. Basically, what characterizes a jail or these virtual systems is a mount point on a file system and a host name. Another neat thing about jails, and why I named it Ouroboros, is recently jails got support for jails within jails. So, you know, ultimately you could keep chasing the tail forever and ever and, you know, have a cloud system within a cloud system. Why you'd want to do that, I don't know, but you could. Ugh, this touchpad is not forgiving when you don't know how to use it. Another drink for me. All right. So, as I said, you've got your FreeBSD host system. You build yourself a template. That's going to take you quite a while. You're building the whole world, which, if you're not familiar with FreeBSD, that's every part of the entire system, everything in SBIN, everything in bin, everything. It's just being built. Finally, once you have everything built, you go into that jail system, you set up all the basic kind of stuff. For example, in my setups, I usually set up a build server so that I don't have to build packages all the time. Of course, you can use the public servers or someone else's, no problem, or just build packages at will, however you like. After you have your base template set up, you make yourself a snapshot. This simply stores ZFS snapshot on your host machine, and from there you can begin cloning that template to create jails on your system. it'll automatically edit all the files and stuff for you so that they get set up, though it's not perfect. So, of course, you're encouraged to check on your config files before you go reloading things that might break stuff. Ultimately, after that, you should be getting going good, having however many systems you want. I've been able to support anywhere from 10 systems that are using, a fair amount of resources on one machine. Aside from I/O, disk is always, the main limiter. On some things that are just simple services, I've been able to stuff like 100 of these jails on there. Because again, lightweight is where it's at. Finally, we provide a command to migrate your jails from system to system. Once again, this just implements a ZFS command and edits your config files for you. One of the main reasons I started this talk, though, is because I wanted to get some input back from the community to see what your guys' needs are, because your needs might not be my needs, and we need to work together to make a better system so that we can all have nice stuff. One thing you should be aware of if you're not familiar with jails and such in the FreeBSD land, certain things need to be configured separately. For example, bind has special configuration settings that need to be set if it's running inside a jail. All these kind of things, they're in the man pages, so be sure to check them out. ZFS on i386 systems is poorly configured. It basically just doesn't give enough access to RAM because ZFS is RAM hungry. So I should have probably also mentioned in the requirements that you're going to need a lot of RAM. This isn't going to work on an old 512 megabyte system. You can check out this talk at this URL when it is available short after the conference. You can email me. You can visit us on IRC, or you can get the code for the scripts on GitHub also after the conference on GitHub. So that is the overview of the talk. Unfortunately, I was not able to get my demo together, but it's pretty much just the output of those make commands, which I will redisplay, because all I would want to demonstrate is how easy it is to manage. So in a live demo, I wouldn't have built World. We would have been here all day. I would have made a snapshot. That takes seconds. I would have made a clone. That usually takes seconds. And I would have done some migration between some of my remote machines, but I really didn't trust the security of this conference either. So, I think I did good there. I would like to open the floor to any questions. If anyone has a good one. Friends of Ghetto Geek have a FreeBSD shirt for you. And I guess.
You can actually migrate these between multiple, like if you have two systems, you can migrate.
Yes, exactly. In my production setup, I have 6 systems. One main host where all the templates lie, and then I just all day deploy from that system to any of the others, and then I can also send templates back to the main system if they need to be modified and such like that. So it's, like I said, it's basically very much like EC2 or other cloud services that you're familiar with, but it's cobbled together from makefiles and Python scripts and FreeBSD. All right, I think that man wins the shirt. I've still got some beer, so is there Any other thing I wasn't clear on?
What's the main mechanism for migrating the snapshots between machines?
That's all ZFS. Like, honestly, for me, the cool thing about this is it's just really small, simple connections between these huge tools that other people developed, and just never thought to put together these this way. Yeah, it's over the network.
Because I know it's like
You can also do it within the same machine.
you had a bunch of different jailed environments on one box. You migrate between.
Exactly. Like I said, anywhere from like 10 to not generally, but I've done up to 100 in stress testing, and like I said, it's one kernel, so it's not like you're doing a Zen system where you're going to end up with all these emulated devices and all these emulated kernels. It's just one. All right. Well, I guess I am a little early. Should have probably talked slower and drank more. Thank you guys, and see you later. Oh, and if anyone needs that contact info, I'll leave it up while you're leaving.